This is Introductory Physics Lab number 2, using Newton's second law to predict observed motion versus predicted motion. Specific aims of this lab are to film a falling object, then analyze the movement in Tracker, collect and analyze the data, develop a computer model on VIDLE, and then compare the actual movement with the computer model. We're looking at Newton's second law again. However, this time in Newton's second law, our F-net will not be set to 0 as it was in our constant velocity lab. This time we'll be taking a look at the effects of gravity and the force of drag on our model. My laboratory was set up outside. My system consisted of a wool ball that weighed 0.048 kilograms. And I set up my XY axis with the origin at the center of the ball, tilted it slightly to accommodate the camera angle. The negative is in the Y direction. The surroundings are the gravity and the air, and I use the corrugated metal divisions to calibrate my dimensions, and the distance between this corrugation and this corrugation was 0.305 meters. Assumptions that we made about our system and surroundings is that the direction is constant during the time interval of our experiment. The only interactions with our system are gravity and air resistance, and net force is not equal to 0. Now we look at the tracker. The graph from tracker, we've got time in seconds on the x-axis and distance in meters on the y-axis. Again, the data points are closer at the top and further apart at the bottom. And the graph is nonlinear. I took the last time reading from tracker and used it in the Lab 2 Start PY program on VIDLE to predict the motion. The calculation loop was modified with the new time, and in this model, weight and drag force were inserted into the model to take account of those two factors. This is a comparison of the gravity interaction with the dropped ball. We can see that the ball dropped faster than the model predicted. When drag was added to the model, it actually underpredicted the motion even more. What does it mean? While the program did approximate the motion of the falling object, it underpredicted it, opposite of the outcome of our paper drop example. Addition of drag to the model slowed the model even more, creating a larger difference between observed and predicted motion. The model can predict, but in my specific case, there is much room for improvement. Possible explanations why the model underpredicted the motion: there could have been a mistake in the formula, or a mistake in the length scale, or a mistake in the actual weight of the object. I did have it weighed at the post office since I don't have an analytical scale. The drop distance might not have been far enough to get enough data points, or the drop distance was not far enough to reach terminal velocity. What if the object had been thrown instead of dropped? Terminal velocity would have been reached faster, perhaps not within the time frame of the video, and fewer data points would have been collected. Also, an impulse would have been delivered to the object, and that would possibly make this more suitable for a different model. We can look at that in tracker. Only 6 data points collected. So tracker is used to measure the motion of a drop ball. The computer model based on Newton's second law was used to predict motion. F-net included drag force and gravity, and in my case, the computer model underpredicted the motion. Possible explanations for the discrepancy: incorrect weight, drop distance too short to reach terminal velocity, or too few data points. Thank you.